So today we're going to be talking about vertical transformations of parabolas. And this is going to be lesson 8.2. So we're going to graph a bunch of different things, but first I want to talk about, so we have various forms of our equations. So we can have y equals ax squared plus bx plus c is our standard form. We could have y equals a x minus h quantity squared plus k, that's our vertex form. And then last but not least, y equals a x minus p x minus q. So we're going to zoom in on this variable a and the impact that it has on the shape of a parabola. So if you remember, our normal parent function goes through the origin, and it has, you can go right one, up one to get to the next point, because 1 squared is 1. You can go, if you take 2 and you square 2, then you go up 4, okay? And then we can reflect those points. So we can also go left 1, up 1, and left 2, up 4. If we went 3 wide, then 3 squared is 9, so that would go all the way up top. I'm going to run out of space on this graph, but know that the third one would go up to 9. So I'm going to draw my graph like this. Okay, so this is our parent function. Okay, so all functions come from this function. So this letter A, it can do one of two things. It can cause the graph to be reflected over the x-axis. It can also cause it to be stretched or shrunk. So we're going to stretch it or shrink it. So in order to reflect it, this A needs to be negative. Okay? And then in order to stretch it, the absolute value of A, because once it's negative, that means it's flipped. So we want to look at just the absolute value of A. In order to make things bigger, we need to multiply it by a number that's bigger than 1. And then to shrink it, then the absolute value of A, again, because we don't care if it's positive or negative, we need to see what the absolute value of it and see if it's less than 1. Okay? And it should actually be less than 1 and greater than 0. So let's look at some A's that would stretch. So if our A was 2, that would stretch it. If it was negative 2, that would also stretch it, because when I take the absolute value of it, it goes right back to 2. 3 would stretch it. Negative 7 would stretch it, because the absolute value of it is actually positive 7, and those values are all bigger than 1. Values that would shrink it would be if A was 1/2. Okay, I'm going half as high. So for that one, we would, instead of going right 1, up 1, we would go up just half of that. Instead of going right 2, up 4, we would go up half of that. So we would go up there. And so we would end up with something that looks more like this. And so see how it's a little bit wider, but definitely shorter? We shrunk it down. Okay. We could also say that maybe negative 1/3, because when I take the absolute value of it, I get a value 1/3 is less than 1. Okay. So now we're going to graph a couple of different ones. So let's go ahead and graph problem 1. We're going to do y equals 2x squared. So first I want to see, okay, so my parent function, it's still in here. So we still have y equals x squared. So once I identify that, then I can say, oh, well, this 2 means that I'm stretching by 2. And since it's positive, that means it's opening up. So let's go ahead and graph that. And I always like to graph the parent function alongside of it. Okay, so we've got, I'm going to graph our parent functions to go 1 squared is 1, negative 1 squared is 1. 2 squared is 4, negative 2 squared is also 4. And I'm just going to graph this in a dotted line so that I can see how it compares to my new graph. Okay, so we can make a table of values if we want and say negative 2, negative 1, 0, 1, 2. So the black line we'll say is our parent function, x squared. So we get 4, 1, 0, 1, and 4. If I double all of those values, right, so I'm multiplying them all by 2, then my new equation will be 2 times x squared. So I can take all of these and double them. So I get 8, 2. 0 times 0 doesn't change, 2 and 8. And let's actually move this so that we can go up. Okay. So if I go negative 2 up 8, so that's 4, I have to go up 4 more. I'm going up twice the distance. So this is 4 and this is 4. And then negative 1 goes up to 2. So again, I'm doubling this distance right there. So I can actually just use my parent function and say, okay, well I normally go right 2 up 4. So I'm just going to double that distance and go up 8. And now we have our new shape. They have a common vertex because we didn't shift it up or down. Okay. All right. So let's go ahead and do one more example, but when we are shrinking it. So number 2. So we'll do y equals 1/4 x squared. Okay. All right. So again, let's go ahead and make our parent function. 0, 0, 1 squared is 1, negative 1 squared is also 1, negative 2 squared is 4, 4, 3 squared would be 9, 5, 6, 7, 8, 9, that would go up there. I have space, we'll go ahead and do it. Okay, so then let's switch colors and let's say our parent function is y equals x squared. So this 1/4 is, I'm shrinking it by 1/4, and because it's positive, it's opening up. So basically, I want to take all of these points that I did on my parent function and make them 1/4 the height. So the vertex stays, but this is now going to be 1/4 that height, and I can reflect that. 1/4 of 4 would be 1. 1/4 of 9, well, that's 9/4, which is 2 1/4. So I go 2 1/4. And now you can see that this is going to be so much shorter. We can go ahead and do 4. 4 squared would be 16. And 1/4 of 16 is 4. So that would be our next point. Okay. Now let's try one where we are reflecting it. So let's, number 3, so we have y equals negative 3 x squared. So not only are we stretching it by 3, but we're also reflecting it. And so another way to look at this is to split it so that you have y equals negative 1 times 3 x squared. And so then our parent function is y equals x squared. Then you can see, oh, I'm stretching by 3, but I'm also reflecting by negative 1. So this one's going to be opening down. Okay, it's going to share the common point with our parent function. But instead of going up 1, it's going to go down 3. So we go right 1, down 3. And then 2 squared would be 4. So we would normally have our point right here, but we want to go 3 times that length. So it would go down to negative 12. So I'm actually not going to do that, but I'm just going to draw my lines very steep so that it shows that's where it would go. All right, so those are the stretching and shrinking, and that is the impact that this letter A has on the graph, that leading coefficient, okay? Now we're going to talk about what this C has on the graph. So for this one, we're just going to look at this form, the standard form, and that is going to shift it vertically. Okay, so if we have y equals ax squared plus bx plus c, this tells us direction of open and whether or not it's shrink or stretched. This tells us our vertical translations. Okay, so if it's positive, it's going up. And if it's negative, then it's going down. So let's go ahead and try graphing a few things. So we have y equals, let's just start with the parent function and say plus 2. So if we graph this, then normally my parent function is here. 1 squared is 1, 2 squared is 4, and then we can reflect. Okay, again, this is my parent function. I'm now going to say, okay, well, my parent function is y equals x squared. So the additional thing that we're doing is we're moving every point up 2. So this point goes up 2. This point goes up 2. This point goes up 2. This one goes up 2. And this one goes up 2. Absolutely every single one of them is increasing by 2. Now if I erase the blue lines and I draw my new parabola, we can see that it has the same shape. We didn't stretch or shrink it. We literally just moved it up 2. And then we can use those two things. If we happen to say, let's, instead of up 2, maybe we had down 2, then that would make it down here. And we would move all those things. But see how from this vertex I can still go right 1, up 1? I can still go right 2, up 4. Whoops, that was not with pen. Right 2, up 4. Okay. As long as it follows the parent function based off of this leading coefficient, then I can graph it using the same general shape. Okay, so that would move it down 2.